So here's your help video for the rational root theorem. It might say like find using synthetic division to find all your zeros, but um, this is going to be a little modified on how I want you to solve for it because you are going to have to find all three zeros from scratch. So we are going to begin. So you guys are going to receive a polynomial, okay? Now it's just on the exam, it's just going to tell you to find all your zeros. So now what you guys have to do is remember this is your guys' p-value and this is your guys' q. There's a coefficient of 1 right there, right? So you guys got to find all your factors of q and all your factors of p. So for q, it's just 1 and 1, right? So now you gotta find all your factors of 50. So 1 and 50, 2 and 25, 5 and 10. I believe that's all the factors of your guys' q and p. So now you guys make your p over q list, right? So plus or minus 1, 2, 5, 10, 25, and 50. All over your factors of q, you guys, which was just 1. So 1 divided by 1 is plus or minus 1, 2 divided by 1, 2, 5 divided by 1, 5, 10 divided by 1, 10, 25 divided by 1, 25, and 50 divided by 1, 50. So remember, this is all of the possible rational zeros. That's it. So to find your zeros, you can only pick and select from this list right there. So you guys set up your synthetic division. So coefficient of 1, negative 14, 35, and 50. So 1, negative 14, 35, and 50. So there are numerous ways you guys can find a zero. Many ways you guys can find your zero, but at the very end, you guys, we should all be getting the same result, regardless of which zero you find. So, right, if I selected 1, you guys, 1 times 1 is 1. Add those together, negative 13. Negative 13 plus 1, you guys, is negative 13. 35 plus negative 13 is 22. And I'm going to stop right there because I know if I continue on, you guys, it's not going to be 0, right? So this is part of the process, you guys. You have to find a 0 from this list, plug it in, and then find the 0. So it's just a continuous thing, right? So I'm going to try negative 5. 1 times negative 5 is negative 5. Add together negative 19. Negative 19 times negative 5 is 95. And I'm going to stop there because, again, the goal is to get to 50. So what I'm going to do is I'm going to try 5 and see how this goes. 1 times 5 is 5. Negative 9. Negative 9 times 5, you guys, is negative 45. Negative 45 plus 35 is negative 10. Negative 10 plus 5 is negative 50. So it took me a couple tries, you guys, but that's the process, right? You keep on trying out numbers from this list to see if it works. So we already know 1 didn't work and we knew negative 5 didn't work. So you just keep on moving on. So we finally found it. So this degree for that coefficient is 1 less than that degree. So since that's x to the third, it's going to be x to the second, and then you continuously go 1 less degree. X to the second, x to the first, and then x to the 0. So we found our polynomial of x to the second minus 9x minus 10 equals 0. Now to find these zeros, you guys, you factor. So negative 10, negative 9, and what two things multiply to negative 10, but when added together gives you guys negative 9, negative 10, and 1. X minus 10 and x plus 1 is equal to 0. So to find your zeros, you guys, just set both of them equal to 0 and solve. And we get 10 and negative 1. So our answers are 5, 10, and negative 1. 5, 10, and negative 1. And that would have been all your guys' zeros for that problem. So, moving forward, let's try a different problem so you guys can see another example. Alright, so we have this one, right? So again, Q, P, find your factors of Q. This is coefficient of 1, right? And your factors of P. So 1 and 1. For this one, 1 and 24. Factors of 24, right? 2 and 12. 3 and 8. And 4 and 6. So, our P over Q list, right? We got plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. And plus or minus 1. So our list is all of those divided by 1, which would just give us all of those back, right? Okay, so now we can select from this list to find a 0, potential 0, right? So 1, 5, negative 2, and negative 24. Coming from this, right? 1, 5, negative 2, negative 24. So now we have to pick one of these to be a potential 0, right? One of those is going to be a potential 0. So this is where you guys gotta guess and you gotta check, right? I'm gonna try 2. 1 times 2, 2. 2 plus 7. 2 plus 5 is 7. 7 plus 2 is 14. 14 plus negative 2 is negative 12. Negative 2 times 2, 20. Negative 20. Oh, sorry. Negative 2 plus 14, you guys, is positive 12. 2 times 12, 24. Perfect. Now, leading coefficient was x to the third, right? So now it's 1 less than that. X to the second, and then this one is x to the first, and then that one's x to the 0. So here's our polynomial. Ooh, what happened there? X to the second plus 7x plus 12 is equal to 0. So again, you know when to factor because when you guys have x to the second, you can factor this or use quadratic formula. And of course, if factoring doesn't work, then you gotta use quadratic formula. So up top, a times c, which is 1 times 12 is 12. B on the bottom, which is 7. Two things that multiply to 12, but when added together give you 7. That's 3 and 4. X plus 3, x plus 4 is equal to 0. So to find our zeros from our quadratic, you guys, just set both of those equal to 0. X equals negative 4. X equals negative 3. So our zeros are 2, negative 3, and negative 4. Now again, just because that's 2, that doesn't mean you could have found these first. And then once you guys found those first, then it's the same thing. Do your synthetic division and then factor using quadratics. So practice doing this, you guys, right? Just practice and you guys should be okay.